Wix.io after this talk. Okay, so I assume that we're in a generalist audience, but you've all heard about AI, and like that's roughly the level that I'm thinking about. But I've been thinking very, very deeply about this over the past little while. The talk is divided into 3 parts. First, we're going to talk about the data. The world is going a little bit crazy. I've been watching AI developments for a little bit. So here are some 2 representative charts that I always like to bring to illustrate the progress that we've been making in AI. Over at the top, you can see, top left, you can see the progress in image generation going from fuzzy face all the way down to being able to place specific types of dogs in specific locations in the image. And on the right, the progress in benchmarks that we can solve handwriting recognition, which was MNIST back in the day, and speech recognition, image recognition, reading comprehension, and language understanding. Progressively better and better and better until we basically exceeded human capabilities. We're no longer even talking about the Turing test anymore. We're now talking about exceeding the Turing test, which is the title of some of these benchmarks. Big Bench benchmark, for example, stands for Beyond the Imitation Game, BIG. At the same time, though, like there's been clear progress, but then at the same time, there's been expectations that have exceeded that progress. This is a chart of earnings call mentions over the past quarter, and AI mania is really through the roof, while AI adoption is still pretty low. If you look at these, the charts on the right, basically telling you that the max adoption in the Fortune 500 of AI is about 14%, whereas 32% of corporate leaders are talking about AI on their earnings calls, meaning they're committing to doing something about it. This is my favorite piece at the recent Google
generative AI, AI as AI.
What happens when
AI.
you feel compelled to give some comment about it? Old MacDonald had a farm, AIO. And you can see that in the open source adoption and interest as well. So here's the chart of the GitHub star history of AutoGPT, which is the most significant AI agents projects. It is got more stars than PyTorch, than Bitcoin, than Kubernetes, than Django, basically every other project in the Python ecosystem. And yet, at the same time, there are still people saying that nobody actually really uses this thing. It just kind of stars itself. This cannot be a sign of a very healthy ecosystem. And I think anyone here who's skeptical about AI engineering, you are warranted, and because there's all these factors showing you that there's significant warning signs of extreme mania and overhype. This is coupled with some real fears that are grounded in the long arc of history. So I like to show these 2 charts of the growth of computing, right? Like that since the dawn of computing, we are increasingly lowering the cost of compute. And at some point, it was going to cross over the capability of all humanity to comprehend how much compute is going on. And the difference between dumb human and Einstein is pretty small compared to the total span of humanity and intelligence. And basically, the point being that artificial intelligence has no natural stopping point that stops at human levels. Like it can just keep going. On top of that, it has a pretty convenient scapegoat. So, for example, when Check was reporting their earnings and their stock plunged about 50% in that week, they blamed it on ChatGPT. Even though if you zoom out a little bit, Check stock has been declining since 2021 because nobody really has a lot of sympathy for the college textbook business model. And finally, if you're like really deep down the fundamentals, if you're trying to read the papers, if you're trying to look at the models, it's really hard to keep up. Here's a plot of the growth of like the major papers over time on the left, and on the right, this is my attempt at my monthly newsletter trying to wrap up all the progress, and that's just some of the news updates. So I've talked a bit about the mania. I talked a bit about the warning signs. Who's actually doing a good job? Who's actually what's real here? And I think money kind of is a good metric of one who's actually creating value. And so I'll point to 4 quote unquote killer use cases. And my definition of that is roughly has some potential to make around about $100 million a year. That's a real business. I mean, I don't know about you. I did comment this on Hacker News, and obviously some Hacker News commenters said, that's like only a few seconds worth of Google revenue, and that's nothing. So you can never win with Hacker News. Generative text, Jasper went from 0 to 80 million in revenue in about 18 months. That was pretty good. Generative images, Midjourney is famous for a very, very small team earning 9 figures in revenue, completely bootstrapped. Coding assistants, obviously we all know about GitHub Copilot. Just a little show of hands, who's actively using Copilot right now? About 30% of the room, 30%. That's interesting. Very good, very good. I wonder how many of you are not allowed, or how many of you actually don't see the value in it. And then finally, chatbots. OpenAI's numbers recently got leaked, and its maintenance went from $20 million in sales last year to $1 billion this year, which is a huge, huge, huge jump. Probably the biggest jump in all history. And it's not just big companies as well. Like the individual developers are also doing well. So there's Peter Levels making $1 million in 10 months with AI, and also Danny Postma selling his copywriting SaaS, kind of like a Jasper competitor. So there's all those data points that are just out there. If you're living in the world, if you're thinking about AI, you're like vaguely interested in it, you've been hearing all these data points, and there's no rough framework to organize them. And I think this is where my strongest thesis comes to help you organize them and put this all together. And it's really about the people that are coming to professionalize in this field, right? There's all these disparate data points. How do you make sense of them? And really, like, I think when I originally pitched this talk for InfoBip, I was thinking about the AI developer, but as I talk to more and more people, the job role and identity that is emerging, that companies want to hire, that people want to name themselves after, is AI engineer. So a couple months ago, I wrote this blog post on the rise of the AI engineer. It's really become a movement around the world. And the central thesis is that AI is shifting right. Here's on the left, we have a meme from XKCD, literally saying, when we need to do some computer vision tasks, we need 5 years in a research team to do something in 2013. Now, of course, it's just an off-the-shelf model or an API that we just call. And now on the right, the way that we make progress in times is to do prompt engineering, which is sometimes just appending different strings. So here's a ablation study of different prompts that we can append, going from a zero-shot performance of 17.7 to performance of 78.7 if we append this thing step by step. It's a very, very different nature of AI progress than it used to be in 2013, 10 years ago. The starting point has also moved. So there's a question on Hacker News about where do I get started in AI engineering? And here are the top two answers. On the left, the answer is, learn everything in machine learning. Do the Engineering Coursera course. Do all the hand derive all the backpropagation algorithms. The other part would be do data engineering, right? Study all the data pipelines, learn your DBT, learn your semantic layer. I suspect that both of these are wrong. Like, you could spend 2 years learning the fundamentals of machine learning, 2 years learning the fundamentals of data engineering, and come out still not as productive as all the other AI engineers that I just named that are making millions seemingly overnight. And I think why this is, you have to have a really clear role, clear vision of where the new opportunities are emerging. And this is the pitch to all of you, that you have the chance to occupy this role if you want to. So traditionally on the left, you have machine learning researcher, research scientist, machine learning engineer, data scientist, research engineer. These are all very well-established fields in existing ML teams. On the right, you have the full stack engineer, the web developer, the product person, whatever you call it. Now, in the middle, there's this role that's emerging that is effectively the AI engineer, the full stack or software developer who is specialized in commanding the full AI stack. And why is this the case? Obviously, you can respec an existing software engineer to do that job, or you can respec an existing ML engineer to do that job. Many of them already are. I just think there's just so much news going on that eventually this is going to be a thing, and it's already a thing. So what makes me so confident and why I'm observing this happen in multiple cities all over the world. It's basically a technical, it's basically an economics issue, supply and demand, right? How many of people are on the left and how many people are on the right? How many people want to make use of AI APIs and how many people are available that are deep subject matter experts that actually don't contribute to shipping products? So the biggest endorsement here came from Andre Karpathy, formerly Tesla, now at OpenAI, saying in numbers, there's probably going to be significantly more AI engineers than ML engineers and LLM engineers. One can be quite successful in this role without ever training anything. And I think that is the whole key that I want to drive to people. Like a lot of times, I think the vision of how people want to be successful in ML and AI is that they have to train their own model. Like that's the vision of success. And mathematically, that cannot be true because there's not enough GPUs to go around. And not more to the point, there's not enough people to go around. There's not that much expertise. And honestly, like there's actually a lot more opportunity and work to be done in the last mile beyond after the model is already mostly trained. So there's economics on the people side. There's also economics on the GPU side. There's all these GPU-rich startups forwarding GPUs, Inflection raising $1 billion, Mistral 113, Breakup Pool Setting and Textual all raising significant amounts, committing to just throw them right into GPUs. All kicked off by Stability, which has the hero image here, where they actually were the first to basically start boasting about how many GPUs they've been hoarding. So you cannot hire these people. You cannot buy these GPUs. And it's also about sociology, right? Like every company that I know, every company that I consult for and used to work at, has a Discuss AI Slack channel. That Discuss AI Slack channel becomes a Discord with a lot more threads, and that thread becomes a formal standalone Discord, which is the one that I run right now. And basically, all these informal groups that are forming within your companies overnight will basically, in my sort of prediction, will basically become formal teams. They'll go from informal groupings of like, hey, like let's meet over coffee or like let's talk about AI on Slack to formal actually product teams because their companies eventually take it seriously enough. That's it. I said all these like non-technical reasons, but it's also enabled by tech. There's a few really key features that I really like about this. So one is the prevalence of prompt engineering. That GPT-3 is basically a foundation model that can few-shot learn a lot of things. And I think it's also very pertinent that it's transferring across from the text domain into something like image segmentation on the top right. I have a little screenshot from the segment anything model where they actually demonstrated that there was few-shot learning or zero-shot learning from things that they were specifically trained on to things that they had never been trained on but still understood. And that's pretty big in the world of ML because that is the source of a true foundation model that is able to grok and generalize beyond the specific training data that was given. Finally, from the products and business mindset, like from that hat, I really like that the shift from ML to AI is the shift in workflow, right? You used to need to collect a ton of data that you need to train your model. And then finally, you put it into products to make it maybe like 5% better. Now with the AI enjoyers and the foundation models, you start with an MVP of the product by taking something off the shelf and prompting it and shipping something as an MVP. Then you get the data, then you fine tune your own model. And so this is a really interesting shift. It's almost akin to the agile movements versus the waterfall. The waterfall would be get data, then get model, then get products. And now you're so agile that you just go straight to products and then you iterate based on the data that you get. And so on the business side, this makes a ton more sense as well. And finally, I think there's a addressable market expansion coming from the expansion of languages, right? There's approximately the same amount of JavaScript and Python developers in the world. And obviously there's a lot more other languages, but those are the two largest communities. Machine learning was primarily stored or locked within the Python world, but now everything's available through APIs. JavaScript developers can access it as easily as well. Therefore, the total market of AI developers and AI engineers has just doubled at least. So there's a second part to the talk title, right? Like I just talked about why AI engineers are forming will become a professional title. People will hire them. People will put them on their CVs and stuff. And I'll tell you a little bit about the emerging stack. But why software 3.0? What is this grand bombastic term? Is it anything to do with Web 3.0? Short answer, no. Software 1.0 and 2.0 is the difference between AI being a lot of ifs, which is the way that I used to code some of my quote unquote AI, and AI being learned weights. So this is the subject of a very seminal essay by Andrej Karpathy about the difference between hand coded software and machine learned software. And this is written and became consensus about 6 years ago. But I think now the discussion has emerged towards software 3.0, where the existence of foundation models has caused yet another shift. For Andrej, he's really thinking about instead of designing a data set, you're designing the prompts. And I like that a little bit, except that it's focused too much in prompt engineering. So I would go so far as to say that he is wrong, which is really, really hard to say when you're disagreeing with a mentor of yours. The central piece that you need to get in your head is that AI plus code is much, 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 much more powerful than AI plus language. And you all, because you're developers, you are so much more powerful than the average AI enjoyer, prompt engineer, whatever how you call it. And this I call the 1 + 2 = 3 thesis, right? That because LLMs can write code, and then you can execute that code, you can verify that code, you can write libraries that abstract and reuse that code. You as developers using AI and becoming AI engineers will be so much more powerful than the typical person just prompting the chatbot. A brief history of code in LLMs. It started roughly about 1 year ago with Riley Goodside showing that you can get GPT-3 to write Python, execute Python, and then feed the result back. So therefore, you're giving GPT-3 a calculator. So now it can do math, where previously it was not precise. Fast forward 9 months since then, we got the general availability of code interpreter now named advanced data analysis inside of ChatGPT. And we're drawing all these beautiful charts just by describing what we want, uploading a CSV file, uploading an Excel file. If you have not tried this, pay the $20 to OpenAI and just try it. It is amazing. I cannot say highly enough things about it. You can also do the same in the other chatbots. They just don't have that sophisticated execution environments. One of my top podcasts and blog posts was actually just about all of this. So you can actually, for example, do a little inspect the requirements on TXT of the coding environment and see what packages are installed. It's pretty fun. And I do think that this is a hint towards the future as well, right? Like in the same way that GPT-3 was augmented by RLHF, and then GPT-3 was augmented by plugins, that failed. GPT 3.5 was augmented by functions, that kind of was a success. Then we got GPT-4 that got a mixture of experts, which is something I was discussed in my George Hotz episode. And finally, GPT-4 plus code interpreter gives a code sandbox that can let it execute code and write code and sort of debug its own code. Once you've seen that magic, I don't have the space to really demo it. Once you've seen that magic, you can see the beginnings of what is probably going to be the GPT-5 paradigm, which is not just taking the same amount of time to inference through all the weights of the model, but also just executing it and seeing the results and then acting on that. Beginnings of agency, the beginnings of autonomy, which is why I call GPT plus code interpreter GPT 4.5, because it is probably the model for what GPT-5 is going to look like. And this is interesting to me because we've actually diverged a lot. We should probably stop calling GPT, because GPT means generative pre-trained. We're no longer actually, like the bulk of the value is not pre-training. Like pre-training is this little thing on the left. That's the left column. This is the presentation that Andrej Karpathy did at Microsoft Build. Once you've done pre-training, you still have fine-tuning, you still have reward modeling, you still have reinforcement learning. And the latest Llama 2 model from Meta was actually estimated to have roughly about 10 times the cost spent on the other stuff than the pre-training. And that is absurd. Like that means the store value of the hard parts have actually shifted away from pre-training into all these more advanced layers on top of it. And ultimately, I think my pitch for you as AI engineers, as people who build software, is to stop relying on the LLM in the core of your application, because you're always going to be limited by the LLM capabilities. You are software engineers, you know how to scale software systems, you know how to compose software systems, you know how to lock it down and secure it. So break them up. These are the little components that I've been pitching in some of my other talks. But just I think the high level takeaway is to mind the fact that if you put the LLM at the core of your application, you will be limited by the LLM capabilities, and we're still not there yet. We have to augment them a lot with code capabilities. So that's the software 1 + 2 = 3 pieces. All right. I know you all wanted to hear about the landscape, so I just want to present the central problems of the AI engineer. These are the sort of solid themes that I've mapped out. You know, it's not very pretty because I don't have artistic talents. But AI UX tooling, productivity, so like Copilot and stuff like that. OSS hosting infrastructure, fine tuning and evals, and finally AI agents. So I'll go really quickly. Coming from the data vault, I used to be part of Airbyte. That's what my job description is on the website, but I'm now independent. This is overwhelming. This is not actually very helpful to figure out the modern data stack. And I recently read a blog post from Dan Stansel who actually simplified all this down to like, all right, what really makes money? What really is the strong determinant of the value here? And of course, it's the obvious one, which is in the data stack, you want to store data in warehouses. You want to pipe it to some business intelligence solution, and then there's some layer for the other stuff: observability, lineage, cataloging, governance, all that stuff. No surprise, the warehouses get the vast majority of the valuation. Snowflake is worth 56 billion now. Databricks now worth 43 billion, and the others are worth slightly less. So, what is the equivalent for the AI engineer stack or a software 3.0 stack? This is the first time I'm ever showing what I think about that. Again, a lot of the VCs have really complicated this thing, and I'm not sure all of these are investable categories, and obviously that's for time to really prove out. But here's where I have the equivalent of the data stack. In other words, this is my advice to you of what to pay attention to, because these will probably be worth real value. Know the tools in this space. I'm going to give you a dump of these tools. Don't worry, you can go to my website later to see all of them. And the point being that if they don't fit within this model, you have to really think about, do they justify their place in the stack for you? I mean, what are they actually doing that is not accomplished in the jobs to be done that are spec'd out here? So the first thing is on the left. Where do you host your models? Either you have closed source models or you have open source models, right? Pretty straightforward. Here's the list. As comprehensively as I've done it, we just released the first State of AI Engineering survey that's done collaboratively with a number of VC firms that I'm close to. And this is more or less the landscape. If you want to choose your models, choose where to host your open source models. This is roughly the framework, all of which have really interesting differences, right? So when you want to do your research, this is something I did for myself. You want to basically think about the features that you want. I just kind of did some qualitative checking and crossing there. But whatever use cases you want to evaluate based on some kind of objective metric. If you don't have an objective metric, the LLM arena from Stanford is probably the best metric to use, because they just use ELO ratings. They just pair up one model versus the other. It's a blind test. You pick one, and whoever wins over time gets higher ranks. Okay, the next part of the software 2.0 stack, the RAG part. This is the vector DBs and the frameworks and the orchestration frameworks. So you got the Pinecone, you got $235 million worth of investment money going into vector databases this year. People just kind of monkey see, monkey do, and warehouses won the data stack. Therefore, vector DBs will win the AI stack. But what's more interesting and up for debate is the frameworks and libraries. Right, 9chains now worth $250 million. Llama Index and the rest are all in that ballpark. Sorry, in that play pattern. 9chain is not in that. 9chain is a different ballpark. So this is all under the category of retrieval augmented generation, and that is the key jargon or term that all of you need to be very, very familiar with. Basically, understanding that there's a difference, or there's a middle point between being pure search or pure retrieval, which is Google or Bing or any other search engine that you want, or pure memory, which is just querying the weights of the LLM for what it has already memorized. That in-between section is the hard problem of retrieval augmented generation. There's entire RAG stack. No one's trying to figure out how to fit everything within the context window, how to retrieve the most relevant chunks, how to chunk properly, how to embed them. All these questions are up for debate, but I strongly encourage you to check them out. And finally, there's the miscellaneous stuff, which is prompt ops and LLM ops, most of which are just dashboards, something like that. I think it's very, very hard to sell, but most people will probably have to develop something like that just on their own, or they buy it off the shelf. And finally, I'll just end with this, which is the big question, the big question mark on the right, which is something that no one's really figured out, and I think it's an opportunity for all of you. What is the sort of UI or BI layer? The two leading options right now, this one just came out yesterday. Vercel V0 is, I would say, sort of outward-facing UI generated for people, and Vtool is more for internal tooling. But again, all of them are sort of the visual layer on top of any of these stacks that you might care to imagine. And the last bit is AI agents. I don't really have time to talk about them, but just think about autonomy and how much autonomy you want to give your agents. I have a full piece on the Latent blog about how you can pose together all these pieces that I just talked to you about to create your own autonomous agents. So where do I recommend you get started? I'm actually working on a Latent University course. It's like a 7-day course. It's like a sampler of here are all the major modalities. Here's where to get started. I recommend you can make your own course. Here's what I recommend you get started for you to be a competent AI engineer, or you can just sign up for the email course, whatever. That's it. I've been Swix. I'm running an AI engineer conf. It's free online if you subscribe, as well as Latent Space. Thank you very much. Oh.